Okay, today I want to explain you about uniprocessor scheduling. Okay, the first subtopic is the types of processor scheduling. Scheduling, the characteristic of scheduling. An OS must allocate resource among competing processes. The second is the resource provided by a processor is execution time. The resource is allocated by means of a schedule. Overall aim of scheduling. The aim processor scheduling is to assign processes to be executed by the processor over time, in a way that meets system objectives such as responsive time, throughput, and processor efficiency. Scheduling objective. The scheduling function should share time fairly among processes, prevent starvation of a process, use the processor efficiently, have low overhead, prioritize processes when necessary. Examples such real-time deadlines. Types of scheduling. There are four types of scheduling. The first, long-term scheduling. Second, medium-term scheduling. Third, short-term scheduling. And the last one is I/O scheduling. Here is the explanation of the types of scheduling. Okay, here is the diagram of two suspend states that can correlate with the next diagram. Here is the diagram of scheduling and process state transition. When the order came, it can transfer to long-term scheduling to the ready suspend and the ready, and it will run and then exit. And when it block or suspend, the medium-term scheduling will send it to the block. Here is the nesting scheduling function diagram. Here is the going diagram of scheduling. Okay, I want to explain first about the long-term scheduling. It determines which programs are admitted to the system for processing, maybe first come, first serve, or according to the criteria such as priority, I/O, requirements, or expected execution time. Controls of the degree of multi-programming. More processes, smaller percentage of time each process is executed. The second is medium-term scheduling. It's part of the swapping function. Swapping and decision are based on the need to manage the degree of multi-programming. The third is short-term scheduling. Now as the dispatcher executes most frequently and invoked when an event occurs. Clock interrupts, I/O interrupts, operating system calls, and signals. And the second subtopic about uniprocessor scheduling is scheduling algorithms. The aim of short-term scheduling is main objective is to allocate processor to time-optimized certain aspect of system behavior. A set of criteria is needed to evaluate the scheduling policy. Short-term scheduling criteria: user versus system. We can differentiate between user and system criteria. User-oriented, response time, elapsed time between the submission of a request until there is output. System-oriented, effective and efficient utilization of the processor. Short-term scheduling criteria: performance. We could differentiate between performance-related criteria and those unrelated to performance. Performance-related, quantitative, easily measured, example as response time and throughput. Non-performance-related, qualitative, and hard to measure. Here is the interdependent scheduling criteria: user-oriented, performance-related. And here is the system-oriented. And now the priorities. Scheduler will always choose process of higher priority over one of lower priority. Have multiple ready queues to represent each level priority. Here's the diagram of priority queuing. Starvation. Problem. Lower priority may suffer starvation if there is a steady supply of high priority processes, and the solution is allow a process to change its priority based on its age or execution history. Alternative scheduling policies. Here's the table of scheduling policies. Selection function. Determine which process is selected for execution. If based on execution characteristic, then important quantities are W is equal to time spent in system so far, waiting. E equals to time spent in execution so far. S equals to total service time required by the process, including E. Decision mode. Specify the instant in the time at which the selection function is exercised. Two categories: non-primitive, primitive. Non-primitive versus primitive. Non-primitive is once a process is in the running state, it will continue until it terminates or blocks itself for I/O. Primitive, currently running process may be interrupted and moved to ready state by the OS. Preemptation may occur when new process arrives on an interrupt or periodically. Process scheduling example. Here's the example of process considered its batch job. Here's the table of process scheduling. Service time represents total execution time. And now the first come first serve. Each process joins the ready queue. When the current process keys to the execute, the longest process in the ready queue is selected. A short process may have to wait a very long time before it can execute. Favor CPU-bound processes. I/O processes have to wait until CPU-bound process completes. And the second is round robin. Use presentation based on a clock, also known as timing slicing, because each process is given a slice of time before being preempted. The character of round robin is clock interrupt is generated at periodic intervals. When an interrupt occurs, the currently running process is placed in the ready queue. Next ready job is selected. This is the effect of size of preempted time quantum. This is the time of the process alert time quantum interaction complete. This is the diagram of virtual round robin. So this can process a lot of program or orders in a slice of time. Shorter process next. The third. Non-preemptive policy process with short expected processing time is selected next. Short process jumps ahead of longer processes. The character of shorter process next. Predictability of longer processes is reduced. If estimate time for process not correct, the operating system may abort it. Possibility of starvation for longer processes. Here's the formula of calculating program burst. Here's the legend. Ti is equal to percent of execution time for each instant of this process. Si equals the predict value for the I instance. Exponential averaging. Here's the formula. A common technique for predicting a future value of the basis of a time series of past values is exponential averaging. Exponential smoothing coefficient. Here is the coefficient value and this is the age of observation. Use of exponential averaging. Here is for the increasing function. The decreasing function of use of exponential averaging. And the third is shortest remaining time. Primitive version of shortest process next policy. Must estimate processing time and choose the shortest. The fourth is highest response ratio next. Choose next process with the greatest ratio. Get the ratio from time spent waiting, subtract with the express service time, and divide by expected service time. Feedback scheduling. 5. Penalize jobs that have been running longer. The no remaining time process needs to execute. Here's the diagram for feedback scheduling. And the feedback's performance. Variation axis simple version preempts periodically similar to round robin, but it can lead to starvation. Here's the performance comparison. Any scheduling discipline that chooses the next item to be served independent of service time obeys to the relationship of this formula. Here's the formula of scheduling. Here's the overall normalized response time of the types of scheduling that I have explained. Normalized response time for shortest process. Here's the difference between the no priority and the priority. Normalized response time for longer processes is actually almost the same. And here is the normalized turnaround time simulation. And now about the fair share scheduling. User's application runs as a collection of processes or threads. User is concerned about the performance of the application. Need to scheduling decision based on process sets. Use fair share scheduling table. And the last subtopic of the uniprocessor scheduling is traditional Unix scheduling. What is traditional Unix scheduling? It's a multi-level feedback using round robin within each of the priority queues. If a running process does not log or complete within 1 second, it is preempted. Priority is based on process type and execution history. Here's the scheduling formula. CPU Ji is equals to measure of process utilization by process J through interval I. Pji equals to priorities of process J at beginning of interval I. Lower values equal higher priorities. base J equals to base priorities of process J. Nice J equals to user controllable adjustment factor. But priority are recounted once per second. Base priority divides all processes into fixed band of priority levels. Swiper is the highest level, block I/O device control second level, file manipulation is the third level, character I/O device control is the fourth level, and the lowest level is user processes. Here's the example of traditional Unix process schedule. Okay, this is about the Uniprocessor scheduling. Thank you for watching.